Hello everyone, this is the review sheet for Unit 2, Algebra Review, Linear Relationships. We're going to jump right in at topic number 1, slope, y-intercept, and direct variation. So number 1 says find the slope of the line that passes through the points 1, 6 and 3, 16. The first thing that you do always is to label your points as x1, y1, x2, y2. And the slope formula is y2 minus y1 over x2 minus x1. And you just go ahead and set up that formula like this with the minus signs from the formula itself. Then you have 16 minus 6 as y2 minus y1. And the x2 minus x1 is 3 minus 1. So you grab your calculator, put that directly into your calculator. 16 minus 6 is the numerator, the denominator is 3 minus 1, and you get 5. The slope is 5, and that is it. Let the calculator do your work for you. It's a positive slope, goes up from left to right. Find the slope and the y-intercept of the linear equation below. Just remember, it has to be in y equals mx plus b to do this, to identify the slope and the y-intercept. So when we have negative 4x plus 8y equals 24, we do have to solve for y. The first way to do that, or the first step in doing that, is to actually just add 4x on both sides. Trying to get the y alone, and you have 8y equals, I'm going to put this 4x first, and then the plus 24 second. Then I'm going to divide by the number that is next to the y. And I will get y equals. And I'm just going to show you right now that I am dividing an 8. And when I divide 4 and 8, it's a fraction. It's less than 1. It's a half. All right. It bring down the x. And then when I'm going to divide 24 divided by 8 is 3. So I'm going to bring the 3 down. So I have y equals a half x plus 3. And the slope is the number before x. So that's a half. And the y-intercept is b. b is 3. So if you put b equals 3, that's fine. M equals a half. And let me move this over and just make sure that you understand that m is the slope. All right, so one of the more difficult ones that I would say, if it was an open-ended question, I would say this is really a tricky question. But if it's a multiple choice question like this, all you have to do is to actually see that they give you 2 points here, but they take away the one of the x values in the points, and the slope of the line is -1. So they're telling you that the slope is -1, and they're giving you the 2 points except for that one x value. You could substitute in and basically see which number could work for -1. All right, you could do that. That's fine for the substitution. But I'm just going to show you the correct way that to do this. Remember, when you have 2 points, it's always x1, y1. x2, y2, and then the slope is -1. So that's all the information that they give you. So I'm going to write down the slope formula. M equals y2 minus y1 over x2 minus x1. So the m is -1. So I'm going to put -1 in, substitute it in for m. The y2 is -6 minus y1, which is -1. Then on the denominator, I'm going to have x2, which is just x. I don't have that value, minus x1. So this is what I have, and now all I have to do is really change this into a proportion. Once I change it into a proportion, I could go ahead and cross multiply. Right? But before I do that, I'm going to do negative, so I'm going to rewrite this as negative 1 over 1 equals negative 6 minus 1 is negative 7. And then x minus 4 I can't really do anything with. So I'm going to use the butterfly method to go ahead and multiply. So it's 1 times negative 7. I'm going to do that first. 1 times negative 7 is negative 7. And then negative 1 times x minus 4 is negative 1 times x minus 4. Like that, like distributive property. When I distribute, it's negative 1 times x and negative 1 times negative 4. So I'm going to rewrite it down here as negative 7 equals negative x plus 4. Negative times a negative right there in that second distribute. When I distribute that negative 1 to the negative 4, when you multiply, it becomes a positive. So then to solve for x, I would just minus 4 on both sides. And this cancels, and you get negative 11 equals negative x. Well, you can't leave negative x, so the number next to negative x is a negative 1. You divide by negative 1 on both sides. This negative 1 cancels, and then x equals 11. If x equals 11, that is your answer. So that means that if you go ahead and substitute that 11 in to this right here, if you replace it with 11, this x, that whole thing, y2 minus y1 over x2 minus x1 would be equal to negative 1. So you could use substitution, or you could use the method that I showed you right here with the proportion. A satellite company charges a one-time fee. A one-time fee is the B, and a monthly service charge. The total cost is always the y, is modeled by the function. They give you the equation. So that is a lot easier than dealing with making the equation. When you have to make the equation, there's a chance that you put the numbers in the wrong spot, right? So in this case, they're giving you the equation. The slope is always the number that is next to the x, that is your m, and the y-intercept is always the other number, that's the one-time fee. So b equals 40 in this case, and m equals 90. Which function has the greatest value for the y-intercept? Just remember, we're talking about the y-intercept, the b. So this b right here for a is 15. This b right here is negative 3. This b right here is 2. And this b is negative 2. So if we're looking for the greatest, we have 15, and 15 is the greatest out of the 4 that they gave us. Write an example of a direct variation equation. Just remember, the direct variation equation must be in the format of y equals mx plus b, because it needs to be linear, and it also needs to have a y-intercept of 0. So any example that you have looks like basically half of an equation. I could put y equals negative 3x. That means the slope is negative 3 and the y-intercept is 0. So it's a straight line that goes through the origin. And I'll just put another one here, y equals a half x. Anything with a y-intercept of 0, and that is in that format, y equals mx plus b. How can you tell it is a direct variation? So I can tell that an equation is a direct variation when the equation is in y equals mx plus b format, because it has to be linear and it has a y-intercept of 0. How can you tell on a graph that the equation is a direct variation? And I could tell that a graph of a line is a direct variation when it crosses through 0, 0 and it's linear. Right? Those two things have to exist for you to have a direct variation. So number 7, a line N passes through the points, and let me just get the highlighter out here. And that information is given to you. Dahlia determined that the equation of a line N is this. Explain the error that Dahlia made while determining her equation. So they're telling you that there's an error. Be sure to include the correct equation in your explanation. So you could do this one or two ways, but the first thing that I'm going to do is always to solve for the slope, because we need the slope. So I'm just going to put m equals y2 minus y1 over x2 minus x1. So the slope is necessary because you need the slope to get any equation of a line. Y2 is 5, the y1 is 7, the x2 is 2, and the y1 is 3. There are no negatives here, so it makes it a little bit easier to deal with. So your m is -2 over -1. I should see a -2 on the calculator. -2 over -1 is a +2. Just checking, that's exactly what the calculator gave me. So now there's two ways that you could possibly do this. I am going to go ahead and find this. That obviously I found the slope first, so that is necessary for no matter what way that you're going to do this. So I'm just going to put down and remind you that when you have 2 points like this, you have to find that slope first. Now, you could use the point slope formula. So you have to remember what the point slope formula is, and it's y minus y1 equals m times x minus x1. So I like this formula the best because once you substitute the numbers in, if you can remember the formula, once you substitute the numbers in, you get the equation of the line. So you're looking for an error here. So I know what the error is already, because her error is that she put this right here. She determined her equation is a -2. It is a +2. So right there is her error. But I'm just going to go ahead and complete the problem. It's y minus y1, which is 7, equals the m is 2, x minus x1, which is 3. You see how nice and easy that is? I do distributive property. Equals 2 times x is 2x, and then 2 times -3 is -6, and then plus 7 on both sides. So this cancels out, and y equals 2x plus 1. So Dahlia definitely made that error with the slope, saying that the slope was negative when it was positive. So Dahlia's error, I just put down, was calculating that the slope is a -2 instead of a +2. All right, and I put down method number 2 if you really wanted to use the y equals mx plus b, because once you get the slope, you could actually substitute all the numbers into y equals mx plus b and figure out and calculate what the slope would be. I'm sorry, what the y-intercept would be as b equals 1. Remember, the y would be 7, or you could put 5 in, but I'm just going to go with y1. I'm going to put the y in as 7, equals m. You figured out the m is 2, times x. The x is 3, and then plus b. The b you don't have. You want to find what b is. Then you multiply 2 times 3 is 6, and you subtract 6 on both sides, and you get b equals 1. Once you have b equals 1, you can substitute back into the y equals mx plus b formula, and you get 2x, y equals 2x plus 1. Right? Either way is okay. All right, topic number 2. If a line contains the points listed in the table, the equation of the line is, listen, really easy, substitute in. Right? So I'm going to go with this right here. I'm going to go straight to this one. You could figure out slope and everything here and you could figure out, if you figure out the slope, let's just go ahead and like not substitute. We're just going to go 0, 5. That point right there is the y-intercept. Remember, 0, when x is 0, the other number is the y-intercept. So right there, b equals 5. So you have to identify that quickly. So if b equals 5, you have 5 here, you have negative 5 here, negative 2 here, negative 2 here. B, C, and D are out. I didn't even find out, I didn't like even have to calculate the slope because the y-intercept is 5. We don't even need to do the slope, right? So that's it. But the slope definitely is going to be negative 2. But I'm just going to put down and just show you y2 minus y1 over x2 minus x1. And I'm going to label in the table, this is my x1, this is my y1, this is my x2, this is my y2. So m equals y2 is 3, minus y1, which is 5, and then x2 is 1 minus 0 as x1. So that's negative 2 over 1, and m equals negative 2. Just like I said here, and A is your answer, but you didn't really need to figure out slope. You could just basically see that the y-intercept is 5 and then pick it from there. So this one is another one that like you should be able to cancel out at least 2 just based on the y-intercept. Remember, I go for the y-intercept first, and that is really going to help you out because this y-intercept is very easy to see. It is 8. Obviously, that is 8. B equals 8. So that means A is a choice. B is 10. That's gone. D is 10. That's gone. So both of these, then I look at the slope and I say, okay, this is going down from left to right. So that means we know that we have a negative slope. Sometimes they give you a negative slope and a positive slope, and then you could cancel it out from there. But in this case, they don't. All right, they give you both negatives. So that means you have to figure it out. So I need 2 points. So I'm going to search my line for another point, and I see that my x-intercept is a good point. So I'm just going to go ahead and do my rise over run like this. Just remember, the graph is going by 2s. It's counting by 2s. So that means that you have to watch yourself here. This is 2, 4, 6, 8. Since you're going down, I'm going to put a negative 8. And this is 2, 4, 5, 6, 7, 8, 9, 10. So my rise over run, remember, it is rise over run. M equals negative 8 over 10. What I like about the TI-84 is that you could input this calculator, this fraction, negative 8 over 10, right? So obviously I don't have any of those here, and I have to reduce the fraction. Really easy to reduce the fraction. You just press enter. And guess what? Negative 4 over 5. Negative 4 over 5 is this one. This is negative 5 over 4. That's canceled. A is your answer. And then you get your reduced form of the fraction without even worrying about anything. Just put the fraction in and then press enter, and you could reduce it. The values given in the table below lie in a line of a linear function. They're telling you it's linear. Use point slope formula to write the equation of this linear function. So point slope formula is y minus y1 equals m times x minus x1. That is point slope. So we're just going to go ahead, x1, y1, x2, y2. All right. So we need the slope. So I'm just going to go and put the slope formula down, y2 minus y1 over x2 minus x1. And m equals, going to put that minus minus, and we're going to do y2, which is 1.75, and we're going to do 1, which is y1. And then we're going to have 0.50, 0.5 minus 0.25. So instead of doing that by hand, I am going to go and bring the calculator over here, hopefully. And I'm going to press alpha X to get to my fraction. And I'm going to put 1.75 minus 1 in the numerator. The denominator, I get 0.5 minus 0.25. I press enter. It gives me 3. Right? Don't try to do it separately as the numerator and denominator. Let the calculator give you what it is. So that's a 3. So now once we have this, I'm going to put my y minus y1 is 1. So I'm just going to put 1. I don't have to put 1.00. The m is 3. The x is just x. Minus x1 is 0.25. So that is my point slope formula, right? Linear function, write the equation of this linear function. So I'm just going to rewrite it. Y minus 1 equals 3 times x minus 0.25. So the first thing that I'm going to do is do distributive property. And distributive property is 3 times x, which is 3x. And 3 times a negative 0.25. I'm going to grab the calculator for this. 3 times negative 0.25. Let the calculator give it to you. So that's negative 0.75. So that's plus 1 and a plus 1. And here is your equation. Y equals 3x plus 0.25. And that makes a lot of sense. That's the equation of the line in slope-intercept form. Y equals mx plus b. Notice that if you do go backwards, the x will become 0. And since this is like a 0.75 jump, going backwards would be a 0.75, like going back to 0.25. And that is the y-intercept. That is your y-intercept, just quickly. Right? So the pattern would be adding 0.75 going forward and then subtracting 0.75 going backwards. But you don't have to do that. But you could, it says use the point slope formula to write the equation. I did. Right? And that's how you use the point slope formula. The equation is y equals 3x plus 0.25. All right, write a line that is parallel to y equals 3x. So you have to have the same slope, different y-intercept. All right, so you have the same slope, different y-intercept, same slope, different y-intercept. And that is that. On the set of axes below, graph the equation the line whose equation is for y equals negative 8x minus 12. This problem right here is not in y equals mx plus b. So that means we need to solve for y. I noticed that the 4 is with the y right now, and it's attached by multiplication. So I'm going to do the opposite of that, which is division. So I'm dividing by 4, y equals, and then we are going to do divide negative 8 and 4. And once we divide negative 8 divided by 4, we get a negative 2. Don't forget the x. And then we are going to divide negative 12 and 4. And we get negative 3. So now I'm just going to go over here. This is y equals, I'm graphing y equals negative 2x minus 3. My slope is negative 2 over 1. I'm going to go down for the rise, for negative, and positive is to the right. B equals negative 3. So if we have a slope of negative 2 over 1 and a y-intercept of negative 3, what you do is you start at negative 3. This is 0, 0 right here. And negative 3 on the y-axis is that point right there. That's 0, comma, negative 3. That is the y-intercept. The slope is negative 2. So we go down 2 like the arrows indicate and then over to the right 1. Down 2 to the right 1. And you keep on going until you can't go anymore. I cannot go anymore. So now you go the opposite way is up 2 to the left 1. Up 2 to the left 1. Up 2 to the left. Up 2 to the left. Up 2 to the left. And then that's it. You can't go any further. I'm going to grab my ruler. And I'm going to connect all my points in a straight line. Like that. I am going to remember that I need my arrows on each end. And I'm also going to need my slope formula, negative 2x minus 3. So that's y equals negative 2x minus 3. And I have a line that goes down from left to right. So that's correct. And I have a I have a y-intercept of negative 3. One more question that's on the bottom. This linear equation contains the point 3 comma k. State the value of k. You could use the graph for this. All right. So I'm just going to go that it says that the x value is 3. So if the x value is 3, I'm just going to go back up to the graph and go over the 3 and go down all the way to the y value. And let's see what it is. Let's see 1, 2, 3, 4, 5. And this is negative. So negative 1, negative 2, negative 3, negative 4, 5, 6, 7, 8, 9. So this is negative 9 down here. That's negative 9. Three comma negative 9. And then don't forget k equals negative 9. Because they want the value of k. They're giving you the value of x. All right. So they want that y value. So don't forget to state it. Negative 9 is your answer. All right, so topic number 3, real-world application of slope. So this is in a city W, the average cost of a gym membership is given by this equation. Again, the equation is given to you, so you really don't have to do much. Where Y is the total cost in dollars, and X are the months of the membership. So what's the sign-up fee? The sign-up fee is the B, right? So the sign-up fee is not $34.99. The sign-up fee for this gym is $49. The average monthly cost for the gym is the number before X. That is your M. So that is $34.99. How much does the gym cost after 1 month? So that means I'm going to take X. I'm going to take the number 1 and substitute it in for X. So this is what I'm going to do. I'm going to put Y equals $34.99. And after 1 month, that's exactly what I'm going to pay. So I'm going to put $34.99 times 1 plus $49. And that is $83.99 is what I'm going to be charged for 1 month in the gym. What's the gym after 2 months? Then I'm just going to go y equals $34.99 times 2 now plus 49. So I'm going to go back to the calculator, do $34.99 again. Instead of multiplying by 1, I'm going to figure out what that is for 2 months. And 2 months is $118.98. That's a lot of McDonald's burgers, right? For the gym. I'm just telling you, $118.98. I'm not saying it's a waste of money, but yeah, not for me. All right, so the cost to rent a boat includes an initial fee. Everybody should join a gym. It's the best. All right, initial fee of $20 plus $2.25 per hour. Write the equation that models this relationship. 225 is the M. 225. That's the amount that gets charged over and over and over again per hour. And then B equals, the initial fee is the starting amount. That is the y-intercept. Remember, when you write an equation down, it is y equals 225x. The x, the slope goes, the rate goes next to the x, and the y-intercept is 20. For number 3, the graph of the linear equation, and they give you this. This is like a little bit of a tricky question. They give you this, and they give you that it passes through this point. Which statement is true? When we went over this in class, so there's a couple of different ways that you could do this. But the one thing that you have to understand is that when they do give you an equation that has a b in it, you have to recognize that that is the y-intercept. So if that's the y-intercept, the 6, the y-intercept is not 0. The y-intercept is not 3. So you could cross both of those out. So either the slope is negative or positive. So the easiest way, I'm just going to tell you, the easiest way is to actually draw a grid, a little sketch of, and I'll put little arrows here for the little sketch. So this right here, this B, just remember, that is x of z, that when x is 0, the other number is the y-intercept. So I'm just going to go ahead and plot 0, 6, which is right there. And then if I have negative 3, 0, negative 3 zeros here. Negative 3, 0, that line looks like a positive line, and it is. The slope is positive. So that's all I had to do. Or you could do this. You have 2 points. Again, the 0, 6 is a point. That y-intercept is a point. And negative 3, 0 is another point. So this is x1, this is y1, this is x2, this is y2. You have the m equals y2 minus y1. I'm going to set up my grid here, the formula. This is negative 3 is 0. So this is negative 6 over negative 3, and the slope is 2. It's positive. Negative 6 over negative 3. And you could do it those ways. All right? Both of those ways. Whatever way you feel suits you. All right, so the cost of renting a moving van can be modeled by this. Again, they give you the equation. Y is the total cost. Y is always the total cost. M for M miles of driving. So state the meaning of the slope and the y-intercept of this function with respect to the costs associated with the van rental. So what does the slope mean? What does the y-intercept mean? So here are the answers here. $3.50 represents the cost charged per mile for the moving van. And then $19.99 represents the initial cost of the moving van. And that is it. All right. All right. So Corey drinks water from a bottle during a bike ride. And all of these questions, they seem to be giving you the equation. So the average water in ounces of his water bottle can be represented by this equation right here. Y is the amount of water remaining after X hours. So hours, X represents hours, and the Y is the amount of water that is remaining. Based on the equation, what amount of water in ounces will remain if Corey rides for, and I don't know why I'm Xing that out, because I thought I have a highlighter. Corey rides for 2.5 hours. So just remember, Y is the amount of water after X hours. So there's your key right there, that X represents time. X usually represents time. So I'm just going to substitute in. Just remember -8. The X is hours. I'm going to change 2.5 into 2.5 plus 32. And once I put that in my calculator, I'll know how much water in ounces will remain in the bottle. So let me just clear this out. And this is -8 times 2.5. -8 times 2.5, putting it in parentheses, plus 32. That's 12. So Y equals 12 ounces. And 12 is your answer, B. That's that. Number 6, a company manufactures radios. First pays an startup cost and then a certain amount of money to manufacture each radio. The cost of manufacturing our radios is given by this function, right? And then the value of 125, they're asking, best represents, well, I'm saying that the 125, you know that the 125 is the startup cost, and only because that represents your B. B is 125. That's your y-intercept. So that's the startup cost. It's not the profit earned from the sale of one radio. It's not the amount of spent to manufacture each radio. That's 525. It's not the average number of radios manufactured. Like, that's not it. It's the startup cost. So that is your B, and that is your answer. Alex opened up a savings account with an initial deposit of $50. Each month, he deposits the same amount of money. He uses this equation right here to determine it, and the total amount of money is in savings account is M months. What is the unit rate, and what is the meaning of the unit rate? So let's look. The unit rate is the slope. So M equals unit rate. That's the slope. So in this case, the M is the 25. So the initial deposit is the B. So that's not what they want. So I'm going to get rid of this, and I'm going to get rid of this. So 25 is good. The amount of money, the amount of month Alex deposits each month, the amount of money, it should say, Alex deposits each month. $25, the amount. 25, the amount of money. So that's out. That's out. Alex initially deposited. No, the initial deposit is $50. So that's out. So it's the amount that Alex is putting in every month. So A is your answer. So number 4, topic scatter plot. We're getting towards the, to the end here. The owner of the coffee shop, blah, blah, blah. There we go. Her data. The scatter plot below. Very good. Okay. That's nice. All right. So here's some information. This is the line. Identify the slope and the y-intercept. Let me get that out of there. Slope and the y-intercept, and explain what they mean in the context of the problem. Slope and y-intercept. I don't even need, if I drew a trend line, by the way, it would be something like this right here. because I'm going to go through the center of all the points as best as I possibly can. And that would be my trend line, right? I'm not going to highlight the trend line. I'm just going to go like this and put an arrow, since it goes down forever until it hits to 0. All right, so the slope is negative 5.9. All right, let's identify it first. And then the y-intercept is 850. So I'm just going to say, all right, so the 850, I'm gonna look at my scatter plot. The amount sold in fluid ounces. The starting amount sold in fluid ounces. Okay, so the slope here is negative 5.9. The amount, and it means that the amount of coffee that was sold decreased. Coffee sold, I should put, decreased as the temperature increased. And that's to a unit of 1. Just remember, when you're figuring out slope or unit rate, it's to a unit of 1. And the y-intercept is 850, and they sold 850 ounces of coffee when the high temperature was 0 degrees Fahrenheit. All right, and that's what the 850 represents. All right, draw the line of best fit. For the scatter plot, we're going to draw that line of best fit through the center of all of the points. And basically, I just did that up above, and this is the same exact one. Just remember, put your arrow here. And what type of correlation does this graph represent? And this is definitely a negative correlation. You could say that it is a weak correlation. It is further away, a weak negative. It is further away from the trend line, but not so much. Like, it would be a little bit more, like if they were asking you weak or strong. Strong would be a little bit closer to the trend line. Negative would be, weak would be a little bit further, like you would see here. But this is kind of like in between. So I just wanted to mention just a weak negative. It's still negative. It goes down from left to right, but a weak would mean that the points are a little bit further away. And then positive means that, or a strong negative would be the points being clustered around the trend line a little bit more. All right, but I'm just going to leave negative right now. All right, predict the amount sold in fluid ounces when the temperature is 70 degrees. So I'm going to go to 70, and according to my trend line, I'm going to hit right there, and I'm going to go directly in the middle of 400 and 500. So just for my trend line that it is hitting up there and it goes directly in the middle, I'm just going to put 450 degrees. If you're a little bit above or below that, that is fine. If you're saying 440 or 460 or something like that, then it is close enough. Number 3, as part of the training program for a triathlon, Maurice completes a 3-year run. Draw a line of best fit. Okay, here we go. We're going to draw the line of best fit. Whenever I try to draw the line of best fit, I try to draw it through the center of all the points. And even so, I'm going to move it down here. And notice that I'm setting myself up for, like, it's actually right at 30. And I'm going to just put it right there. And this way it makes it easy for me to write an equation. It doesn't have to be 30. It could be right above 30, and you could say it's 32. But just keep in mind, when you're drawing it from the y-axis, that you're going to have to eventually use that y-intercept right there to create the equation of a line. All right. And Now that's what they're saying. So draw the line of best fit. We're done. Write the equation. So we need the M and the B. So my B right away is 30. But I need 2 points. So I'm going to use that 30. And I'm going to use this. All right. I'm going to make that point there. And I'm going to go down 1 and over 1. So my slope is 1 over 1. And that to me is a pretty easy go. 1. And then my y equals x plus 30 would be true. So if it's not 1x, it could be something that's close. If you put, like, let's say 4 over 3, that's fine. That is very, very close. 5 over 4, that's very, very close. So you're right in the ballpark, and you know that you'll be okay with something like that. And here it is. Slope is how much the total time decreases each week for running the 3-mile race. For running the 3-mile race, and the initial time it took to run 3 miles at 0 weeks. And that's the initial time. So that is the explanation of the slope and the y-intercept. Which statement best describes the data in the scatter plot where the y values are increasing as the x values are increasing? So the best way to do this, and we gave this question on a quiz, is to actually go ahead and sketch. All right, we're going to sketch a scatter plot, and we're going to put it together like this. This is the x-axis right here. This is the y-axis. So the y values are increasing. So the y values are increasing as the x values are increasing. So the x is increasing. And I'm just putting all scatter plots. And the y is increasing as well. So that's what that looks like. So we're going to have a trend line that looks like that. The x value is increasing, the y value is increasing. The data could be best by a vertical line. No, it's not a vertical line. Gone. Horizontal line? No, that's horizontal line. A line with a positive slope? Yes. Negative slope? No. All right. So the best way is to actually draw it, and then you can get an idea of what it is that you're looking at. Right, the scatter is topic number 5, linear regression. The scatter plot below shows the number of milligrams of medication in a person's body for 3 hours of medication. Which kind of correlation does the scatter plot show? So this right here, I'm going to draw a trend line, even though it doesn't say to. That is my trend line, and you know that is a strong negative correlation. And that's it. Okay, so this is the first question that we're talking about, linear regression equation. And then correlation coefficient. Explain what that correlation coefficient suggests in the context of the problem. This is a Regents problem, and I'm just going to get my calculator up and put these numbers in. Remember, this is my L1. This is my L2. Just remember, when the proctor asks you to reset the calculator, just make sure that when you press mode, because when you reset your calculator, this stat diagnostics, and I'll go down to it, stat diagnostics will be off. You have to go to the right and press enter to put it on. Then you go stat, and then edit. So you look at your list. If there are numbers there, you go up to L2, press clear, and then enter. Then go up to L1, press clear, then enter. And you'll clear those lists. If you delete a list, if you delete anything, you press stat and you go to setup editor, which is 5, and then you press enter. And then once you go back to stat, you'll have L1 and L2 there again. Right? So I'm going to put the numbers in the list. L1, I'm going to start with L1 as 160, 180. So 160, 180, and then 200, and I have 200 again, 200 twice, right? No, 220. Almost made a mistake there. 240, 260, and 280. I typically count. There's 7 numbers in because I see that there's 8 here. So 7, I'm going to count 1, 2, 3, 4, 5, 6, 7. So I'm okay. So now I'm going to go over to L2 and put 126 and 103 in. 126, enter, and then 103. Let me move over just a little bit so I could see. Enter, and then 82, 75, 82 again. Yes, you have to put it in again. And then 40. And then 20. So I have all the numbers, the lists match up. And so now I'm going to press stat. And I'm going to go over to calc. And I'm going to go down to 4 and just press 4. Don't go down to it. And then enter 5 times. And then you notice that I'll have the A. Where's my pen? All right, so I'm just going to put down the A equals, does it say, it doesn't say what to round to, so I am going to round to the nearest hundredth. Right, it says round to the nearest hundredth for the correlation coefficient, but it always says that. So I'm going to do the same for the linear regression equation. So we're going to have 0. This is negative, by the way, negative 0.79. All right. And then the B is equal to 249.86. I'm rounding it to the nearest hundredth. So this is 5 and the next number is 7. So that's where I'm getting that from. And then the R equals 0. And that's negative 2, negative 0.95, rounded to the nearest hundredth. All right, so now we're ready. Write the linear regression equation, y equals negative 0.79x plus 249.86. Let me just check again to see that that's a positive y-intercept. It is. And then the correlation coefficient, let me just write it again over here, 0.95. So this is very specific of what you have to write. Just remember, you have to explain what the correlation coefficient means in the context of the problem, and they will always have this type of question. And I just wanted to type that off screen. There's a strong negative correlation between sale price and the number of new homes available. It's a strong negative correlation. If you put very strong, that's fine also. It is very close to -1. So you just have to say strong negative correlation between sale price. Just take a look at the table and then just write down exactly what it says, sales price and the number of new homes available. And that is going to get you full credit. So the which relationship can be best described as a causal relationship. Causal. So we're just going to go through and remember correlation doesn't really specifically cause event B. In a causal relationship, the cause A, it really causes B. So height in intelligence, that is not a causal relationship. Shoe size and running speed, no, that is not a causal relationship. Number of correct answers on a test and test score, yes. That is the cause. When you get more answers correct, the test score will go up. And that's the cause. The number of students in the class and number of students with brown hair, no. Which situation describes a correlation that is not a causal relationship? So you're looking for something that doesn't specifically cause something else to happen. So the length of the edge of a cube and the volume of the cube, that is a definite cause. So that's a causal relationship. The distance traveled and the time spent driving. Yes. Causal relationship. That's gone. The age of a child and the number of siblings the child has. No. That is a correlation. While it might be true, it's not a direct cause. And that's what you're looking for. The number of classes taught in a school and the number of teachers employed, that is a causal. That is something that the A event causes the B event. More classes, the number of teachers employed increases. All right? Or changes. Okay, software company keeps a record. We're going to write a linear regression equation for the set of data. Again, we're going to put this into L1 and L2, and then we'll come back and share our results. Okay, I put my list in. I cleared my list out from the last question, and now I am ready to go. Press Stat, and then Calc, and then over to 4, and then enter 5 times. You calculate, and you have your slope, your y-intercept, and it's all rounded to the nearest hundredth already. And we're going to round that linear, the correlation coefficient, to the nearest hundredth as well. All right. So it says to write the linear regression equation. I'm going to just write it y equals, and I'm just going to put 0.41 x, and then that is a negative 2.31, and that is what you write. State to the nearest hundredth the correlation coefficient. So I'm going to put r equals, when you state correlation coefficient, make sure you put the r, 0.9, and I'm not going to put 8 because the next number is a 6. I'm going to put 9. And then it says state what the correlation coefficient indicates about the linear fit of the data. And we're going to put, there is a very strong positive correlation between the annual advertising budget and profit. Period. There is a very strong positive correlation, very strong. It's 0.99. And that is it. So our last topic is graph interpretation, and we are just going to interpret what these graphs mean. And in the section N, we're just going to describe each section as linear, nonlinear, and increasing and decreasing. So section N is linear, and it's increasing, going up from left to right. Section P is linear. So this is section P. It's linear, and it's increasing. Let me change my section Q. Is that? So it's definitely linear. And it's not increasing or decreasing, but the slope is 0. Right here. Okay, so you have linear and increasing for section R, the blue section, and that is it. That's pretty easy. Which graph shows a function in which the rate of change in y-intercept are both negative? The rate of change has to be negative. That means it has to go down from left to right. And the y-intercept is below, so that means the b has to be negative. So let me just talk about the slope. It has to go down from left to right. This is a positive slope. So that's out. This is a positive slope. So that's out. This is negative. And this is negative. So we have either C or D. And there's one y-intercept that's negative. This is 0. The y-intercept is 0 here. So this y-intercept is negative. So that's your answer. C. Alrighty. So the graph of this function is shown below. For which interval of x is the function increasing and linear? Okay, so let's talk about increasing first. So this part is increasing and linear. The rest of it is not. And then this part right here is decreasing and linear. So between -4, let me just put this in red. All right, -4 and -2. Increasing and linear, A is your answer. And that's it. Number 4, John left his home and walked 3 blocks to school, shown in his accompanying graph. So, explain where John was walking the fastest. How can you tell? So from here to here, John, not so fast. Then from here to here, that's steeper. So A to B is definitely steeper. And then, now just take a look at those lines. And definitely from A to B, John was walking the fastest. And John was walking the fastest between A and B. The line is steepest during that interval, which means his rate is quicker. Was the fastest. All right, the graph below represents the jogger's speed during her 20-minute jog around her neighborhood. Which statement best describes what the jogger was doing from the 0 to 2 minute interval of the jog? So the speed right here, 0 to 2, let's just talk about this and highlight it, because that's what they are specifically. Was she standing still? No, the speed is increasing, so she's not standing still. She's standing still here. Well, actually not. She's not standing still here. But she's maintaining her speed here. So, but she's increasing her speed right here. So B is your answer. She's not decreasing the speed. She's not jogging at a constant rate. This would be a constant rate, that flat line. that has a slope of 0. This is a constant rate of 6 miles per hour. This is a constant rate of 3 miles per hour. This is increasing speed up to 3 miles an hour. So B is your answer. All right, and that ends the review sheet. Thank you for watching, and I hope that helped. All right, see you next time.